Hello. So I'm solving Philip Newman's hashtag no touch this. This is an anti-king Sudoku, which means that digits that are separated by a king's move in chess, or in other words, digits that are diagonally adjacent to each other, can't be equal. So for example, because there's a 9 here, there can't be a 9 in this orange cell because those touch diagonally. It is called anti-king now, I believe, because of the analogy to anti-knight Sudoku, where digits that are separated by a knight's move in chess, one across, two down, or vice versa, can't be equal. But originally it was referred to as no-touch Sudoku or untouched Sudoku, and that's where the pun in the title comes from. So let's give this a try. And also normal Sudoku rules apply, so digits 1 through 9 in each row, column, and 3 by 3 marked region. So let's give it a try. So I see at first some classic Sudoku moves that I can make without using the anti-king constraint, and I'm guessing that's what's happening here, is that I will be filling some things in with classic Sudoku, and then the remainder of it is going to let me focus in a little bit more on the anti-king constraint. For instance, I've got this corner box here that only has 3 open cells, and I have a 7 there that sees 2 of those cells, so that's now a 7. I also have a 4 here that sees 1 of the remaining cells, so that places a 4 there, and now I have an 8 here. And I'm guessing that I'm going to get some symmetric moves in the bottom right corner because the bottom right corner has the same layout. And in fact I do, because I have an 8 here that sees these 2 empty cells, so the 8 goes there. 2 sees this cell, so 2 goes there, and 1 goes there. Now the next thing that comes to mind is, can I do something analogous to that in the top right and bottom left corners? They look a little bit less restricted because they don't have this additional digit in the very corner. But it's possible that now that I have these filled in, I can do something useful with them. So the digits I still need here are 1, 3, 4, and 9. And I can see that I have 2 1s looking at this 2 by 2 area. So this one sees these 2 cells, and this one sees these cells. So 1 has to go here. This 9 sees 2 of the 3 remaining cells, so 9's going to go there. 4 puts 4 here, and the last digit is a 3. Can I get this very last corner? I have a 5 here and a 5 here, so between them they see these 3 cells, so 5 has to go there. And now I need to place a 2, 3, and 6 to finish the box. And I actually don't get to totally finish off this corner, so I have a 2 here, so 2 is in one of those cells, can't go here, so that's 3 or 6. This cell sees a 6, so it's 2 or 3, and this could be any of 2, 3, or 6. So I think that's the point where I have to start using anti-king. I haven't even touched it yet, but now that the grid's a little bit more filled in, it should be easier to focus on where we can apply that constraint. So let's have a look. Now, there are kind of 2 places we can look at this stage. So we can look at these 2 by 3 open areas, or we can look at the center 3 by 3 box that's completely empty so far. I've solved this puzzle before, so I know that I want to look at this center box first, but I think that if you're solving this blind, either of those would be equally valid, and we are going to have to look at both of them in the end. But because I've solved this before, I know that the thing to look at is these 5s that are surrounding this region. So I've got these 2 5s. This one sees these 3 cells by Sudoku here and by king's move here and here. This one sees these 3 cells. And just by regular Sudoku, this one sees the cells in its row, and this one sees the cells in its column. So I can place a 5 here. And I'm going to look for anywhere else that I can do something like that in this middle box. I see these 2s. This one eliminates 2 from all of these cells by Sudoku and by anti-king. This 2 eliminates 2 from these cells. I can't quite go further than that yet, but I do know 2 has to be here or here. So the next question is, if there's nothing else like that, which you can keep looking at this point. I did keep looking at this point. I didn't find anything else in the middle. So if you kind of stall out on that, where do you go next? Well, I've got these 2s and I've got this 5, and I also have a 5 over here, and I have a 5 down here, and I have a 2 down here. So let's see if we can use those. So I've got 5 and 5 here, which block 5 out of all of these cells. And I have a 5 here, which blocks 5 out of this cell. So the only cell for 5 in box 6 is this one. So that's my 5 placed. How about 5s and 2s up here? Not down here because they're already placed, but 5s and 2s up here. So 2 is in one of these cells. So whichever one of those it's in, it can't go in these cells because it's already placed in the column somewhere else. That's called pointing. That's a pointing 2s. This 2 blocks 2 out of those cells. This 2 blocks it out of this cell, so the only place for 2 in this region is here. Similarly with 5s, this 5 blocks 5 out of these cells, this 5 blocks 5 from these cells, and this 5 right up here in the corner blocks 5 out of that cell. And now I only have 2 empty cells in each of these rows at the top, so I'm going to pencil mark what goes in them just so I don't have to remember it. My remaining digits here are 3 and 8 in the row, and my remaining digits here are 6 and 9 in the row. But I have, and you can see the pencil mark checker is going off here, I have a 6 touching this 6, 9 by value diagonally. So it can't be a 6 by anti-king, so it's a 9. Now, does this give me anything else that I can maybe bring down here, or that I can bring into the middle? Although actually, before I do that, I'm going to look at this column because that's just as restricted as the stuff I was just dealing with. And I'm going to observe that the 2 digits I still need there are 6 and 8. Okay. So now what have we got? I've placed a 6, I've placed a 5, I've placed a 9. The 6 might give me something useful. So 6 keeps 6 out of these cells. This 6 keeps 6 out of these cells, so 6 is in one of those cells. Not incredibly useful so far, but we'll hang on to that. Maybe there's something going on with this trio of unknown digits. So these have to contain 3, 4, and 7. The 4 makes this unable to be a 4. This 3 touches the cell diagonally, so that is a 4 or a 7. So that's not quite going to unstick us. Okay, now we need to start considering stuff that maybe is a little bit less restricted, or at least less restricted looking, because it seems like we've stalled at this point with easy digits, unless there's something I'm just not seeing, which is very possible. So I'm going to go down here. These cells are 3, 6, 7, and 9 because those are the remaining cells I need in the row. This cell can't be a 9 by anti-king, and it also can't be a 7 because there's a 7 in the column already. That gives me this 3, 6 pair, so neither of these can be 3 or 6. And the 9 that I placed earlier makes that a 7. So now I have 2 9s looking into this center box. And I also have this 9 that sees that cell, so one of those is a 9. That's a start. These cells contain my remaining digits in the box, which are 1, 3, 4, and 6 in some unknown order. I can eliminate 4 and 6 in this cell by Sudoku, and I can eliminate 1 and 4 here, 1 because of the column, and 4 because it sees this cell by anti-king. That actually gives me a 3, 6 pair in the box, which makes this a 1. And which makes this a 4. And that's potentially useful because now I have 2 1s looking into this box, and another 1 over here, so one of these cells is a 1. And I have 2 4s looking in. There's a 4 there and a 4 there, so one of these is a 4. But I'm still not fully rolling along. This column and this column are starting to look pretty tight, so I'm going to pencil mark those and see if I see anything. So my remaining digits in this column are going to be 3, 4, 6, and that's it. So 3, 4, and 6. And you can either just spot this with your eyeballs or notice, as I have because I have the checker on right now, that this can't be a 6, and it also touches a 3 by anti-king. So it must be our 4. And so that's either a 3 or a 6. That 4 makes this cell a 7, makes this one a 3, and makes this one a 4. Now this was the other column that I identified as getting a little bit restricted. So that's going to be 2, 3, 7, and 8 as my remaining digits in the column. This cell can't contain 3 or 7 because there's a 3 in the row and there's a 7 touching it. And this cell can't contain 2, 7, or 8 because it touches a 2 and 8, and there's a 7 in the row. So that's our 3, and that's actually going to resolve the entire column just by Sudoku. The 3 also makes this a 6, which unwinds everything down here in the bottom and bottom left of the grid. So what are my remaining digits needed here? So I need a 1, an 8, and a 9 here. That can't be a 1, that can't be a 9. And I'm also noticing that I now have a 6 in this row, which resolves this 6-8 pair. And that makes this definitely a 9. So let's finish up. So this column still needs a 1, a 3, and a 9. I can't place a 1 or a 9 in this row, therefore this is a 3. I can't place a 9 here, so this is a 1 and a 9. That makes the 8-1 pair go this way around. The remaining digit in this row is a 7, the remaining digit here is a 2, and the remaining digit here is an 8. And that is how you solve Philip's #NoTouchThis.